Well, here's the proof: interplanetary climate change, which is NASA's hottest secret. Now, we can look through and find the smoking gun of all 2012 scholarship, because we can look at all the planets and the sun and see changes just like we see on Earth. And I'm going to show you a little bit of that. This is a composite graph of solar activity based on core samples from the Antarctic and the Arctic. And what you're seeing is the total amount of sunspot activity. This is what it's been doing in the last few years. We are now at a point where the only time the solar activity was higher than it was right now just so conveniently happens to be 11,000 years ago, which in ancient teaching is associated with what? What happened 11,000 years ago? Atlantis fell, right? Could that be related to the solar activity? Hell yeah. So we're now at the strongest point in 8,000 years since that happened. Mercury has grown a magnetic field when MESSENGER went by in 2008 that was not seen in the 70s with Mariner 10. That's a big change in Mercury. Venus has had a 2,500% increase in this green glow on the night side that you can see there. That's active oxygen. So the atmosphere of Venus is changing back into something that's breathable. Mars is growing clouds and ozone, as you can see right here. There were no clouds on Mars before. That's brand new. The polar ice caps are melting on Mars, and they're actually calling it global warming in the mainstream media. But there's no SUVs on Mars, not that I've ever seen. Jupiter is having these white ovals that were disappearing between 97 and 2000, 3 of them, and then they all meld into one. And this scientist, Dr. Philip Marcus, believed it would cause Jupiter to warm by 18 degrees in only 10 years. Now, if that happened on Earth, what would happen to all life on Earth as we know it? Toast. It's toast. So there's a massive global warming going on with Jupiter. That was the prediction based on what would happen in 2000. That's about the time he did this prediction. He said 10 years. Look at what happens 8 years later. Jupiter is having raging thunderstorms and global upheaval. Towering storms more than 100 kilometers tall. The rare storm is a sign of recent turmoil on the planet. And here's the picture. These bright hotspots were never seen before. This is extra heat that shouldn't be there, and the colors of the rings are changing. Then you go out to Saturn, you're seeing this plasma torus that's grown. All this red area wasn't there before. That's all this charged energy coming from the sun. Jupiter also has one around it, which I just didn't have time to show you in this presentation because we had to shorten it. You're seeing massive X-rays coming out from near the equator of Saturn. That's also a new phenomenon. Again, you're seeing a hotspot, just like the one I just showed you on Jupiter, the raging storms, the global upheaval in 2008. Same thing happened in 2004. Where the heck did all this energy come from? The planet just goes, this energy comes out. It's amazing. Uranus, as of 1986, looked like green pea soup with hardly any peas. Just the green part. Nothing to see. It's just very flat. Now, this is false color, so that's why this is brighter than this. We're not so much concerned about the color, we're concerned about these little guys, because that's what we didn't see before. These are huge storms. Now remember also, Voyager 2 swept by Uranus, so it saw the whole planet. It didn't just see the side that we see. So even with a satellite going past, we're now seeing all these storms that were not there before. And you're starting to see that happen. It was called featureless as a cue ball, but now Eric Karakoshka is saying, really big changes. Now this is more typical of NASA, when NASA says, ground-based observations show seasonal brightness changes, not well understood. Oh, moving on. They try to downplay this stuff. But this is interplanetary climate change. This is something that's happening to every planet. And all they do is they tell you that it's based on the tilt angle of the axis to the sun. The sun is heating it up because the pole is tilting or because the equator is tilting. And whatever the planet is doing, they just alter it for that planet and say, oh, well, it's got to be caused by the tilt angle of the planet relative to the center of the sun. Not so. Neptune, 1989, relatively few bright clouds. But between 96 and 2002, there's a 40% increase in brightness in the near-infrared range. This is very significant because, obviously, this could not be caused by anything we normally understand. And it's the same thing that's happening throughout the rest of the solar system. It's all doing the same stuff. What you're going to see now is a description, a visual description of how it's been changing. So check this out. You watch down here, you can start to see how it grows over just 6 years. So that's phenomenal. I mean, that's like turning on a lampshade and having light suddenly burst out of the planet that wasn't there before. The near-infrared range is not visible to the eye, but it's just above the visible level. So it's within the spectrum of what can be seen if you had the right eye to see it. So you can do that with a camera, you just can't do it with the naked eye. Now, Pluto is experiencing global warming even though it's moving away from the sun. There's been a 300% increase in its overall atmospheric pressure. This whole system tells us that Earth changes are not unique to the Earth. They're happening everywhere in the solar system. But even on Earth, we're seeing things that are not attributable to the ordinary climate change that we would think of as being caused by SUVs. Volcanic activity since 1875 has gone up by over 500%. Sea level is increasing, temperature is increasing, tornado activity is increasing, natural disasters are increasing, the inflation-adjusted economic losses are increasing. Here you see the red indicates how much heat there is at the bottom of the Pacific Ocean, on the floor of the ocean. And then what you're seeing is 85 and 96, or 99 rather. So in 14 years, you see a substantial warming on the bottom of the ocean. Now guess how the scientists explain this? Well, of course, the sun is warming the top of the ocean. And then those warm particles just start sinking down, 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 which is what they're going to do, right? And they sink to the bottom, and they warm up the bottom of the ocean. That's got to be it. They warm up the bottom of the ocean, they sink down. So the next time you ever want to boil up some hot dogs, just get a hairdryer and it works great. Why wouldn't you do it that way? You'd probably take 3 hours to boil it. It's ridiculous. Heat rises. That's the first, one of the most basic laws of thermodynamics that we all know. But not here. Something's happening inside the Earth. Well, just as we were talking about climate change in the solar system, we now have a change in this presentation. My microphone started malfunctioning at that point in the talk, and so what we've done is to move this shoot here to Joshua Tree, California,